Okay, let's try a couple different problems. So examples 4 and 5 are kind of similar, but they're a little different from each other, but they're very similar. And they're ones where we're going to kind of make a diagram or a table to help us, because there's a lot going on in these. It's a lot of kind of trial and error for these two. So for the first example, suppose you're an engineer programming the automatic gate for a 50-cent toll. The gate should accept exact change only. So they don't want any extra money. Don't put a dollar bill in, right? They want exact change. How many coin combinations must you program the gate to accept? So if anyone's driven on highways, like going out of state, let's say up to New Hampshire or something like that, a lot of times you hit toll roads. Nowadays we have, your Easy Pass or something like that that you can swipe through, or you may have a toll booth taker who you can give actual, money to and get change. But there are some tolls still that are exact change only, where you throw your money in and you just keep going. So that's what's going on here. It's a 50-cent toll. And we need to figure out how many different coin combinations could exist for that toll. And we're going to consider 4 kinds of coins. So your $half coins, let's see if we can get that going. Your $half, I know they're rare, but there are $half coins worth 50 cents. They should say quarters, not quarts. Quarters, dimes, and nickels. We're not going to consider pennies. A lot of machines don't take pennies, so we're only going to consider silver coins. And again, I know there are the coin $1 as well, but we're taking exact change, so we're not going to include those. So here it's trial and error. I'm going to make myself a little list. I'm going to make myself our little table. I'm going to write $half. So remember, $half are 50 cents each. I have quarters. Quarters are 25 cents each. I have dimes that are 10 cents each. And I have nickels that are 5 cents each. See if we can get this to focus. All right. And this is like where trial and error comes in. I got to figure out, well, how many combinations can I do? So I usually like to start when I do something like this with my highest values first in this case. So one way we could pay the toll is if someone had one $half coin, right? So if they have one $half coin, those are worth 50 cents, then that's all they need. They would just put in one $half coin, that's 50 cents, that's it. So if you're using one $half, you don't need any more change. So you would use one $half, 0 quarters, 0 dimes, 0 nickels. Now, after the $half, like you're not going to use 2 $half or 3 $half, right? That's it. It's just one and you're all set. So otherwise, all of our other combinations are not going to use $half. They're going to use 0 $half, right? Because if you have a $half, then you've already paid. So let's think about other ways that we could pay the machine. So now I'm going to think about my quarters. That's going to be my next highest amount. Think about, well, how could I pay using quarters? So the easiest way to pay with 50 cents is to use 2 quarters, right? Because 25 cents plus 25 cents is 50 cents. So I could use 2 quarters, and then I would use nothing else. It's possible, though, to use just 1 quarter, right? So if I'm fishing around in my car, maybe I don't have 2 quarters, so maybe I only have 1 quarter. So if I use 1 quarter, I have 25 cents, but I'm missing 25 cents now. So what are the other possibilities I can do to make up the other 25 cents? And here there's more than one option, right? If I need 25 cents, I could use 2 dimes and 1 nickel, because that gives me 10 cents plus 10 cents plus 5 cents. So there's that missing 25 cents. But I don't have to do that. I could use maybe only 1 dime. So if I have 1 dime, that's 10 cents. I still need 15 cents. I could use 3 nickels. Or maybe I don't have any dimes and I only have nickels. So if I need 25 cents, I could use 5 nickels. So these are other ways that I could use quarters. And this is trial and error, so I'm kind of just going one at a time and thinking about, okay, let's focus on quarters here. What are the different ways I could use quarters? And then I'm filling in the rest. So I did the $half first. Well, what if I focus on $half? Now I'm focusing on quarters. So I could use 2 quarters or 1 quarter. Those are all the combinations. So now let's say we're done with quarters. So let's think about dimes being the largest, right? Because there's no other combinations to use quarters. That's it. Try them out, play around with the different numbers. Nothing else is going to work. So my next highest is going to be dimes. Well, if I need 50 cents, I could use 5 dimes and be done, right? But I could also use 4 dimes. So if I use 4 dimes, then I'm missing 10 cents. So I would have to use 2 nickels to make up. Yeah, but let's say I had 3 dimes. Well, that's 30 cents. So now I'm missing 20 cents, and I have nickels, so I'd have to have 4 of those, right? Because 4 nickels times 5 cents each is 20 cents. Well, let's say I only had 2 dimes. Well, that's 20 cents. Now I'm missing 30 cents, so I would need 6 nickels to make that up. Let's say I only had 1 dime. That means I need 40 cents, so I would need 8 nickels. And finally, let's say I had no dimes, right? I have no half dollars, I have no quarters, I have no dimes, I just have nickels. And I need to make 50 cents. So I have 5 cents, I need 50 cents, I'm gonna need 10 nickels. And those are all my combinations, right? If I can't have 0 nickels, if I have 0 nickels as my biggest coin, then I have nothing left, right? So here I made a strategy. I used a table. I did trial and error, kind of thinking about, okay, what combinations could I make? And I see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different combinations. So how many coin combinations must you program? 11. So this is a great one to use a table. And again, when I'm talking about money, I like to start with the largest values first. I find that the easiest. So I try to use that largest coin as like my start, think about all the combinations there, and then I eliminate that largest coin and move on to the next largest. So I did that first. I could use $1/2. That was the only way to use a $1/2, and I moved on. Now quarters became my next highest. So I focus on just quarters. So how could I use quarters? I could use 2 quarters or I could use 1 quarter. And then I filled in the combinations there. And then I pretended like I had no more quarters. And then I went over to dimes. Well, let's say dimes was my highest, right? How could I do that? And then at the end, let's say I have no dimes, I just have nickels. So for me, that strategy works. I start with my highest coin first and then kind of think about all those combinations and then pretend like that coin's gone. I don't have the coin anymore and work my way down. Example 5 is kind of similar. So here we have 4 runners who are in a 1-mile race. We have Maria, Aretha, Thelma, and Debbie. Points are awarded only to the woman finishing first or second. The first place winner gets more points than the second place winner, which makes sense. How many different arrangements of first and second place winners are possible? So I'm focusing on first and second place winners, right? So I don't care about third and fourth place here. They're not going to get points. I just want to know who's getting points. So how many different arrangements? That also means combinations. So different combinations. Now you can make a table here again too. So this would be a great strategy, very similar where you can make a table and think about the different combinations. I'm going to do something a little bit different. So I'm going to make more like a chart instead, or like a diagram. So I have 4 people. I have Maria, Aretha, Thelma, and Debbie. And I'm going to just use their first letters of their name just to help me get organized. So different things can happen, right? So one thing that could happen is that Maria could get first place. Right? Now, if Maria got first place, well, Aretha could get second place, or Thelma could get second place, or Debbie could get second place. Now I could go further, right? I could figure out who gets third, who gets fourth place, but it doesn't really matter. I'm focusing on first and second place winners. So one thing that could happen, or one group of things, is that Maria could get first, and then it could be Maria and Aretha, it could be Maria and Thelma, or it could be Maria and then Debbie, right? So this leads to the idea that Maria could be first, and then Aretha is second, Maria is first, and Thelma is second, or Maria is first, and Debbie is second. So right there, we have 3 possibilities, with just Maria being first. But it doesn't have to be Maria first. It could be Aretha first. So if Aretha is first, Maria could be second, Thelma could be second, or Debbie could be second. So again, let's say Aretha's first. Well, Maria could be second, Thelma could be second, or Debbie could be second. So there's 3 more possible combinations here. All right, well, maybe it's not Maria or Aretha. Maybe it's Thelma. Maybe Thelma takes first place. And then maybe Maria takes second. Or maybe Aretha takes second. Or maybe Debbie takes second. So it could be Thelma first and Maria, Thelma first and Aretha, or Thelma first and Debbie. So I have another 3 combinations. And you guys can see where I'm going hopefully at this point. So we haven't forgot about Debbie. Debbie could be first, and Maria could be second, Thelma could be second, or Aretha could be second. So it could be Debbie in first and Maria in second, Debbie in first and Thelma in second, or Debbie in first and Aretha in second. So I have 3 more combinations here. So how many different arrangements or combinations of first and second place winners are possible? Well, there's 12. 3, 6, 9, 12. And again, that's not really including your third and fourth place winners, right? So if we want to include third and fourth place winners and take this further, then we could find more combinations, right? Because Maria, Aretha, Thelma, Debbie is different than Maria, Aretha, Debbie, Thelma, right? So all the different combinations matter. Here we're just focusing on first and second place, so I don't need to think about third or fourth place, but we could take that further if we needed to, right? So just as a side note, thinking about Maria, for instance, being first. Well, if Aretha is second, then it's possible that Thelma could be third, and then Debbie could be fourth, or it's possible that Debbie is third and Thelma is fourth. So you have all these different combinations that you have to think about when you're thinking about counting arrangements or counting combinations. And this idea and this idea are sort of similar. So we can make a chart, like a table, or we can make a diagram to help us figure out the combinations.